Hello, everybody, and welcome to Chem 1115, Chemistry and Society, Chapter 10, lecture on the notes. Just a reminder to please go read the chapter in addition to these notes and use these notes in reference, as you prepare to get ready for the test and for the quiz. So in Chapter 10, we're talking about brewing and chewing, as your book calls it. So things that are related to the chemistry of cooking and the chemistry of preparing foods. Here's a reflection for you to think about on your own. So the internet has all these, tongue maps about what the tongue, where the bitter section is and where you can taste sour and where you can taste salty. But in actuality, the entire tongue tastes all the senses pretty much equally. So the receptors for sweet and sour and salty and bitter are on all of your taste buds. It's not like there's a sour section and a bitter section and a salty section like people once thought. So what happens is the molecules interact with the receptors. They're like little sensors. And so it's like a lock and a key, right? The binding of the molecule, that would be the key, going into the lock, that would be what's on your tongue, sends a signal to your brain. And then your brain interprets it as salty, sweet, sour, bitter, whatever. So fun facts about chocolate. It contains a lot of really interesting chemicals that give us reasons to like chocolate. And I'm not going to make you memorize the molecules that are in chocolate, but just so you know, it's a really complicated mixture. And so here could be a fun experiment for you to do, a chocolate taste test. And here's a link for milk versus dark chocolate. So maybe this is something that you actually want to try. So here is a recipe and variations of that same recipe. And the link, they're trying to crack a joke, how to cookie with science, get it, cookie. And so here are different recipes and different variations on that recipe and how the resulting cookies came out. All right, in chemistry, when a reaction occurs, the reactant that you run out of first is called the limiting reagent. And that same premise holds true in cooking too. If you have 16 slices of bread and 10 slices of cheese, how many grilled cheese sandwiches can you make? Well, if you're using 2 slices of bread for each sandwich, 16 divided by 2 would be 8. So you've only got enough bread for 8 sandwiches, but you've got 10 slices of cheese. So which one are you going to run out of first? You'll run out of the bread first, right? So that means that the bread is our limiting reagent. And the one that you have extra is called the excess reagent. So we chemists use that same principle. And if you go on to take future chemistry classes, you'll do calculations involving those chemical quantities. So water is a good medium for cooking because it can absorb a lot of heat before it changes phases from the liquid phase to the gas phase. So for instance, if you're boiling something in water, right, you can fill your pot and it takes a long time for all that water to boil away, right? Because it can absorb a whole lot of heat. And even if the water's actively boiling, it still takes a lot of energy to vaporize the water from the liquid phase to the gas phase. And a lot of times, even if you're cooking pasta, I know I do this when I get impatient. If the water's not even boiling yet, I just throw it in there because that water is pretty close to the temperature you want it to be. So you can try that yourself sometime. And let's review chemical and physical changes. A physical change does not alter the composition, and a chemical change does. So we use heat as a primary means of cooking, right? So for instance, if you have an egg that you're cooking, if you melt the margarine or the butter, melting is a physical change. But when you put that raw egg in there and that raw egg goes from here to here, right, that's a chemical change. And so that's basically what we're going to spend the rest of this lecture talking about, chemical changes during food cooking. If you've ever wondered why raw meat is red and cooked meat is brown, it's due to a chemical reaction. It's called the Maillard reaction, actually. And it occurs at a high temperature between sugars in the protein molecules. And it is a chemical change. So browning when you take a raw red piece of meat and you cook it and it turns brown, is a chemical change. And there's a video that you can check out too. Sous vide is cooking in water as a medium, and you take your piece of meat or whatever it is you want to sous vide, and you don't let the substance interact with the water. So the water is just your medium, but it never actually touches your substance that you're cooking. So this looks like a delicate piece of fish, and that would be a good way to cook a delicate kind of fish that could be overcooked easily or fall apart easily. It takes longer, but it's a very uniform way to cook. And that's also a chemical change. When you cook something in the microwave, we've talked about the electromagnetic spectrum already. So a microwave oven, why is it called that? Because it emits radiation. So tell your roommate that the next time you guys are cooking in the microwave. A microwave oven is called a microwave because it emits microwaves in the microwave region of the electromagnetic spectrum. And so the energy doesn't break the bonds in your molecules that you're cooking. It causes them to rotate and vibrate at a lot faster speed, and higher energy means higher temperature. But microwaves, the actual waves, do not penetrate deeply. And so that is why sometimes if you're trying to scramble an egg in your microwave, you end up with one section that's just totally destroyed and one section that's kind of raw. There's some other kinds of ways that you can cook without heat, and those are called drying and salting and curing. And this has been around for forever, right? And so you can preserve food by removing all the water. If you get rid of all the water containing any bacteria that can make you sick, they get out of the food and it preserves the food. And then salting has been around for forever, right? You add salts to kill the bacteria, and that prevents the food from breaking down. Bacteria won't want to break it down because it's full of salt. And so this is an example of osmosis where water's drawn out, right? So this has been around for forever. And it is a way to prepare and store food without using heat. If you've ever thought about smoking, like you put a food in your smoker. I know on Thanksgiving, we like to smoke our turkey instead of bake it in the oven. Smoking involves the protein collagen, and it's in the connective tissues of the meat. And if you do it at a correct temperature over a long period of time, you convert that collagen, which is what gives meat its structure. Like if you have a piece of meat that's really tough, it's got a lot of collagen in it that hasn't been converted into gelatin yet. So collagen conversion that happens slowly, that will turn it into gelatin, and that is a chemical change as well. And so it gives your meat a very nice tender fork feel. And then if you've ever noticed the smoke ring when you smoke meats, you know, they get kind of a pink area. And it literally does look kind of like a ring around a certain area of the meat. When you slice through it, you can see this ring. And that is from interactions from the smoke, particularly nitrogen dioxides. And it makes a chemical change as well. All right, an emulsion. So eggs are nature's perfect emulsifiers. And when you take an egg and make it into mayonnaise or other emulsions, they contain amphiphilic molecules, which is just another way of saying they contain both a water component and an oil component, and they allow oil and water to hang out with each other in harmony. Because as we've said, the structure of oil is not compatible with the structure of water until you add an emulsifier, and then those two will get along just great because the emulsifier has both a water property to it and an oil property to it. Fermenting is something that occurs when microorganisms like yeast digest sugar and they don't use any oxygen to do it. It's called anaerobic. And so again, this has been around for forever as well. And when you ferment something, you produce ethanol and carbon dioxide as the waste. So you can use yeast to leaven bread. You use those carbon dioxide gases to raise your bread. I'm really into making breads, and I use lots and lots of yeast for doing that. You can also use yeast to make alcoholic beverages, and that's the ethanol. Distillation is actually a physical change. This is the one example of a physical change that is something that we talk about. And we've talked about distillation before when we talked about taking salt water and turning it into fresh water by distillation. So if you've got a mixture of liquids, you heat them, and then the one with the lowest boiling point boils off, and then you can collect it. But because boiling is a physical change, it does not alter the composition. We would say that distillation is a physical change and not a chemical change. And here's a link that you can watch on distilling whiskey. Extraction is when you take molecules out of other substances. So extraction is something you will do in organic chemistry a lot. And so when you make coffee, for instance, or tea, you pour the hot water over the beans that have been roasted and you get an extraction. And so here's another link about that process. And so maybe this is something you can do. Again, this chapter has a lot of fun things you can try. Try all these different materials, so long as you're not allergic to them, because obviously if you're allergic to it, don't eat it. But try this and then see what you find. So that's where we're going to stop for today for chapter 10. I hope you have a great day, and I'll talk to you next time. Bye.